equilibrium of the bodies. All right. Yes, Siddharth, can you tell me that? What is the meaning of the word equilibrium?
Sir, when a body is in the state of rest or the
Hmm.
state of linear or rotational motion under the influence of several forces, it is said to be in the state of equilibrium.
Yes. Only one word was missing over there. When you say it is in a state of rest or uniform, linear or rotational motion. Have you understood?
Yes, sir.
Okay. So we say that when a number of forces are acting on a body and under the action of those number of forces, here, if the body is in a state of rest or state of uniform, linear or rotational motion, we say that the body will be in equilibrium. So therefore, on the basis of this, we have two types of equilibrium. One of them is a static equilibrium and second one is dynamic equilibrium. When I say that the body is in a static equilibrium, which means that the body will be in a state of rest under the action of number of forces or
Two forces.
under the action of number of moment of forces. Just like here in first example, under the action of two forces, all right, here this force and this force, the body is in a rest position. That is, the body is in a static equilibrium. And over here you can see that here the moment of forces are acting on this beam balance. One of them is going to be a what? A clockwise moment, and this is going to be a what? Anti-clockwise moment. But you can see that the pointer is in exact the middle position. So we say that the anti-clockwise moment is equal to the clockwise moment. That is the algebraic sum of all the moment of forces about the pivot is 0. Have you understood this? So
Sir.
therefore, we can say under the action of several forces or under the action of number of moment of forces, if the body is in a state of rest, then it is a static equilibrium. Then another equilibrium we have learned is a dynamic equilibrium. That is under the action of number of forces or under the action of number of moment of forces, if the body is in a uniform linear motion or uniform rotational motion, then in that case the body will be in the dynamic equilibrium. That is, one of the example was motion of a raindrop. Everyone knows about this. Same thing happens for lift of an aeroplane. All right. Then last time we have discussed the third example, that is a motion of a planet around the sun. This is the one of the important example of the dynamic equilibrium. And in that, we have learned that because of this gravitational force, this planet is able to revolve in a circular orbit. If this gravitational force is not acting, then this planet will move along this red arrow. All right. So this is the reason why it is said that the planet will have a displacement or it will have a velocity along this tangent, along this red line. Is everyone is clear with this fact?
Yes, sir.
Yes, sir.
Okay.
Yes,
So
sir.
so
Yes,
you have to
sir.
remember the gravitational force is acting along this blue arrow, which is towards the center of the sun, and the planet is going to have a displacement or velocity along this red arrow, that is along this tangent. All right. So such a force which is along the radius and towards the center is called as the centripetal force. All right. We are going to discuss about the centripetal force in our next chapter. All right. Now, here, if you see the direction of this force and direction of this displacement, the angle between them is 90. All right. And you know the formula for work done. That is force into displacement into cos theta, where theta is the angle between force and displacement. So as theta is 90, so cos 90 will be 0, and here the work done becomes 0. And what is the meaning of this? If the work done by a force is 0 means what? It is not going to change its velocity, or sorry, it is not going to change its speed. You always remember that. If a work done is 0, then that force will not able to change its speed. Alright, I am not saying velocity, I am saying if work done is 0, then that force is not able to change its speed. Clear? That's why when the earth is revolving around the sun, here it is moving with a uniform speed. Alright, so as the planet is moving with a uniform speed, so we say that the planet, motion of the planet around the sun is a dynamic equilibrium. Clear? So this, whatever the explanation that I have given, we are supposed to remember it. Why they will ask a question, explain why the motion of a planet around the sun is in a dynamic equilibrium. You have to explain these equations over there. That is, the angle between centripetal force and the displacement of a planet is 90. Hence, work done will comes out to be 0. And when the work done is 0, that force is not able to change the speed of a planet. That's why the planet is moving with a uniform speed and it is in a dynamic equilibrium. Clear? Now, here, the second example, the circular motion of a stone which is tied to a string. Now, it is the same explanation is same applicable for this part also. Just like the planet is revolving around the sun in a horizontal plane, in the same manner, if I taken a string and to that string I am going to attach a stone and I am moving that stone in horizontal plane. Which plane I said? Horizontal. Alright. Now when the stone is moving in the horizontal plane, everywhere the gravitational force acting on the stone will be the same. And because of that, every time here I am pulling that stone inwards and pulling that stone inward. So whatever the tension produced in the string by my hand, because of that tension, the stone is able to perform the circular motion. Just like in our previous example, the gravitational force by the sun was a centripetal force. In this case, what is the centripetal force? The tension produced by my hand in a string will be the centripetal force. And because of that, the stone is able to revolve in a circular orbit. We have to always remember that if we want to produce a circular motion, there has to be a centripetal force. Clear?
Yes, sir.
Yes, sir.
Okay. So
Yes, sir.
I'll just summarize this here. When the stone is moving in a circular orbit or in a horizontal plane, the centripetal force is given by the tension produced in a string by my hand. Alright, again the centripetal force is acting towards the center. My hand will be the center of a circular orbit, and here the stone is moving, have a velocity along a tangent. Again, the angle over there is 90, and again work done is comes out to be 0, and the stone is moving with a uniform speed. So this is again an example of dynamic equilibrium. Clear, children?
Yes, sir.
Okay. So these are
Yes,
the
sir.
okay. So this explanation
Yes,
you are
sir.
supposed to remember. All right. Now, so at the end, here we'll just summarize our conditions of equilibrium. In an exam, they will always ask a question, state the conditions of equilibrium. Now, here the first condition will be the resultant of all the forces acting on the body should be zero. If when number of forces are acting on the body and but all the forces they are trying to cancel each other. All right. Just like here, if you place a book on a table, the weight of the body is cancelled by the normal reaction of a table. So in that case, I will say the resultant of all the forces acting on the body is zero. This is your first condition of equilibrium. Second condition is for moment. What is the equation? What is the statement written over there? The algebraic sum of the moment of all the forces acting on a body about the point of rotation should be zero. What is the meaning of this statement? If you remember the example of beam balance, in that there are two moments. One of them is a clockwise moment and second one is anti-clockwise moment. And if I take a algebraic sum, the word algebraic sum means what? One of them has to be taken as positive and the other one has to be taken as negative. That is called algebraic sum. So if you take the algebraic sum of this clockwise moment and this anti-clockwise moment, if that sum comes out to be the zero, then you say that the body will be in an equilibrium. So you are supposed to remember the statement from the exam point of view, and whatever the words given out there, you have to write the same words in your answer. Are you clear with these two statements?
Yes, sir.
Okay. So
Yes,
first,
sir.
okay. So first statement is about the resultant, the net force acting on the body should be zero. Then the body will be in equilibrium. Or if the algebraic sum of all the moment of forces is zero, then you say that again the body will be in a equilibrium. So these are the two conditions of equilibrium. Now we'll proceed towards our next slide. That is a very important point. That is the principle of moments. Now, here we have to learn, we have to remember about only the moments. We'll talk about only moments. All right. So, last time we have learned that how we calculate the moment of couple, or I can say the resultant of moment of forces. Avanti,
Yes, sir.
how we calculate the moment of couple.
The moment of couple is the magnitude of either of the forces
Hmm?
multiplied by the perpendicular distance between them.
Between two forces, correct. Or I can say that the moment of couple is the sum of the moment of forces forming that couple. Is it? Yes, children, is that correct? The
Sir,
moment
can
of,
you repeat? I did not
Sir,
hear
can you
you.
repeat?
yeah, I'll repeat that. The moment of couple is basically the sum of the moment of forces forming that couple. Means there
Yes,
can
sir.
be,
Yes,
yes.
Yes, sir.
Yes, means there can be a anti-clockwise moment or there can be a clockwise moment. So you have to take the algebraic sum of those moments. All right. So therefore, what is the principle of moment? In a state of equilibrium, if the body is in equilibrium, then there will be, what will happen? The sum of anti-clockwise moment will be equal to the sum of clockwise moment. All right, or vice versa. When I say the body is in equilibrium, so directly you should take the meaning that the clockwise moment is equal to anti-clockwise moment. Or if I say that the clockwise moment is equal to anti-clockwise moment, the body will be in equilibrium. All right. So they are, both of them have the same meaning. Clear? So exam point of view, you have to remember the statement of this principle of moment. That is, in a state of equilibrium, the sum of anti-clockwise moment is equal to the sum of this clockwise moment. Or the same statement that already we have learned. the algebraic sum of all the moment of forces acting on a body about the axis of rotation is 0, then the body will be in equilibrium. Clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So this statement is very important from the numerical point of view also, as well as from the theory point of view. All right. Now, the last point from this chapter is the verification of this principle of moment. We have to apply this principle now. Also, on this principle, we have also practical. All right. So at time of practical, you will get more. You can verify directly over there. Okay. So first, here we'll see the theoretical part of it. Now, the physical balance or your beam balance actually works on this principle of moment. All right. So sometimes in an exam, they ask a question for 1 mark. What is the working principle of this physical balance or beam balance? So beam balance works on the principle of moments. All right. So here you can see a diagram over there. Everyone pay attention over here. What we have done is that we have taken a meter scale. All right. And when I say a meter scale means its length will be 1 meter or its length will be 100 centimeter. All right. Now this meter scale is pivoted about this point O with the help of this rigid support. So this scale is fixed or this scale is pivoted about this point O. Now we have taken the two positions on this scale, that is point B and point A over there, and at this point A and at this point B we have attached two springs over here. All right, and to these two springs we have attached a load. At point B we have attached a load W2, and at point A we have attached a load W1. Clear? Have you understood the construction over here?
Yes, sir. Can you explain it again?
Yes. Okay. Remember this. This is a kind of your beam balance or physical balance. So in that you can say that here there is a meter scale is over here. Meter scale means its length will be 1 meter or its length will be 100 centimeter. Now this scale is pivoted or fixed about the point O with the help of this rigid support through a string. So this scale is suspended over here and it is fixed about this point O. Now at point B and at point A we have attached two springs over here. You can see that at this point and at point A. All right. Now to each spring we have attached a load. Here is the W2 and here is a W1. Clear? Now here you can see that, can I say if this scale is in an equilibrium over there? Because it appears that the scale is uniform over here. Actually it is this, they have shown the picture by adjusting the scale in an equilibrium. All right, you actually have to move this spring over there. Imagine that if the spring is over here, see the cursor over here, and I will try to move the cursor means I am trying to move the what spring, and when I bring that spring at point A, at that time it is observed that the the scale is in equilibrium, means the scale is horizontal, the scale will be uniform. Have you understood what I said?
Yes, sir.
Just imagine that. Just imagine that if this spring is at this point of cursor, will this scale will be horizontal? Yes.
No.
No. It will not be horizontal. All right. So I am moving that spring, and when I place that spring at point A, it is observed that that spring, the scale is comes out to be horizontal. So I will say it is uniform. I will say it is in an equilibrium. Now, when I say that any body is equilibrium, so what you will say about its moment. Kaushiki.
Can you repeat your question?
So listen carefully. When I now am saying that this scale is in equilibrium, so what you will say about its moment?
Sir, it will be straight.
It will be. Yes, tell me. Don't worry about it wrong or correct here. Just tell me what you know. We have learned the condition of equilibrium.
Can you repeat my?
Yeah. You just tell me the condition of equilibrium. If the body is in equilibrium, then what happens to its moment? Yes. Anyone help her?
Anti-clockwise.
Yes, Medansh. Medansh.
Anti-clockwise will be equal to clockwise moment.
Yes. When I say that any body is in equilibrium, just like this scale is horizontal or it is in equilibrium, so I will say that there will be two moments over there, and one of them is going to be a clockwise moment, and the other one is going to be an anti-clockwise moment, and their sum will comes out to be the 0. All right. So in this case, here you can see that this position of this arrow over there. Now the W1 here, this moment is going to be the what? Clockwise moment. Is it? See the direction of line of action. See this arrow. It is going to be a what? The clockwise moment, and this W2, it is going to be the what? The anti-clockwise moment. All right. So which means that when I say the scale is horizontal, so this clockwise moment will be equal to the what? This anti-clockwise moment. Clear? Kaushiki?
Yes, sir.
Kaushiki, give
Yes,
me
sir.
answer.
Yes, sir. Yes, sir. Yes, sir.
Okay. So now we are going to calculate the clockwise moment over here. All right. So you can see that this is your clockwise moment, and everyone knows the formula for clockwise moment or moment. That is a force. Here the force is W1 into the perpendicular distance
L.
between the axis of rotation or the pivot
Center point.
and the line of action. So L1 is the perpendicular distance between the pivot and this line of action. So that's why the clockwise moment of the weight W1 is W1 into L1. Same thing happens for anti-clockwise moment. So this is your anti-clockwise moment. So it is going to be the what? Force W2 into the perpendicular distance between line of action and the axis. And you can see that this L2 is the perpendicular distance over here. So W2 into L2 will be the anti-clockwise moment. And if I say that the scale is in equilibrium, then here we will say that this clockwise moment will be equal to anti-clockwise moment. So this is your clockwise moment, W1 into L1, and W2 into L2. This is your anti-clockwise moment. Clear, children?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
W1 into L1 is a clockwise moment, and W2 into L2 is a anti-clockwise moment. Hence, we'll say clockwise moment is equal to anti-clockwise moment. Clear?
Yes.
Okay. Now,
Sir.
Sir.
wait, just let me ask a question, then you answer out. Is Smithy is there? Smithy.
Sir, I can't hear you.
Okay, hello. Is my voice is audible now, children?
Yes.
Yes, sir.
Okay.
Yes, sir.
Is Smithy is there? Okay. Rishita, are you there? Rishita. Okay, she is not there. I think. Hannah, are you there?
Yes, sir.
Okay. So Hannah, my question to you is that here you can see that uh, what is going to be the relation between the force and the momentum here? You can see that here the here for L2 is less and L1 is more. Is it?
Yes, sir.
Okay. So you tell me that here which weight is more? W1 is more or W2 is more? Which weight will be more?
So can you repeat?
Yes, I'll again repeat the question. You can see that the moment arm L1 is more and L2 is less, is it?
Yes, sir.
Okay, so my question is that which weight will be more? W2 will be more or W1 will be more?
So W2 will be more.
And can I ask how come is that?
So because in this case L1 is more than L2. So for
Okay.
it to be equal, for
Yes.
for it to be equal, W2 has to be more than W1.
Yes, very important. Good, very good. So always remember that whenever you have to balance the large load, all right, whenever here W2 here is a heavy load, all right, and if I want to balance that with a smaller load, so I have to increase a what? The momentum. So momentum will be more. Or if you see the position of this equation, then in that case here from our diagram here L1 is more than the L2, and if you want to maintain this equality sign, the W2 has to be more than the what? W1. Is everyone is clear with this fact?
Yes, sir.
Yes, sir.
Okay, so if you want to balance a heavy load, all right, with a smaller load, see what I'm saying. If you want to balance the heavy load with a smaller load, for the smaller load, the corresponding moment arm has to be more. Just like here, the W2 is more compared to W1. So I am balancing this W2 with the W1. So therefore, my moment arm for W1 is more. Clear?
Yes,
Yes,
sir.
yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So, so here, this is what you have to remember the theory part of this chapter. Is everyone is clear with this? Anyone have a doubt? You can ask.
Sir,
Yes.
sir, do we take anti-clockwise moments as positive and clockwise as negative, right?
Yes, exactly.
Sir, so why, how come the clockwise moments will be equal to anti-clockwise moments?
Because you can see that here for this is your anti-clockwise moment and this is your clockwise moment. See how they are balancing. Here W2 is more, so its momentum is less. Now, if here W1 is less, so its momentum is more. So that's why they are balancing each other. Have you understood?
Yes, sir.
Okay. So if weight is more, then its momentum will be less. And if weight is less, then its momentum will be more. That's why they are balancing each other. Clear?
Okay, sir.
We will start with our numerical parts over here.
Yes, sir.
So the first numerical, children, we'll start with the numericals. Everyone open a textbook and notebook. So first, and I'm going to read the first here. So you can see that page number 11, numericals. And they have written a one note over there. For a uniform rod, its weight acts its midpoint. You have to remember this fact. When a body is uniform, all right, or horizontal, its weight will always act through the midpoint, that is through the center of gravity. All right. So I'm going to read the first numerical. So you just note down the given thing and then you tell me formula and the solution. Everyone, the moment of force of a 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. So my question is to Ayushi Tiwari. So tell me the given thing so that I can write.
Sir, the moment of force is given,
Yes, and it is how much?
and it is 10 Newton.
Sure. What is the unit of moment of force, Ayushi?
5 Newton meter.
Yes. So see the unit and then you decide what is the what? The SI unit. And then they have given a force. Force is,
Force.
yeah,
Yes.
force is
10
5
Newton.
Newton. Force is 10 Newton. Yes, correct. Force is 10 Newton. Done, children? Everyone have written the given thing?
Yes, sir.
Okay.
Yes,
So
sir.
now, so everyone knows the formula. So write it down the formula. Yes. Avanti, what is the formula? Moment of force formula.
Force into distance.
Yeah, which distance? The perpendicular?
distance.
Perpendicular distance.
Yes, the perpendicular distance. All right. Now, what is the solution now? Arrange the formula for perpendicular distance first and tell me the solution. Arrange the
Sir,
formula
it would be
for
10 in
So